So today we will discuss minors and cofactors. So here what we are going to discuss is what is minor of an element or what is cofactor of an element of a determinant. For example से बताता हूँ. Suppose one of your determinant is 5, 3, 8, 2, 0, 1, 1, 2, 3. It's a very simple concept only. Minor of an element Aij, it is obtained by deleting the ith row and jth column. So for example, suppose if I need minor of the element 8, minor of 8, so this 8. So that is denoted by M13, minor of the element A13. It comes in the position A13. So minor of the element A13, that is M13. That is that is how we denote this. That is equals, just eliminate the row and column containing M13. That means the remaining determinant 2, 0, 1, 2. So which is 2 into 2, 4, 4 minus 0, which is equal to 4. So minor of the element 8, this 8 ka minor, that is 4. It is denoted using the letter M13. Minor denoted using the letter M13. Okay, so minor of an element of a determinant of order n is a determinant of order n minus n. So either minor of an element of order 3 by 3, determinant 3 by 3 का था. So minor आएगा 2 by 2 का determinant. You just forget about all those things. Just simply if you say minor of an element, it is the determinant obtained by deleting the row and column containing that element. That's all. Now, cofactor of an element, cofactor. So cofactor of 8, and that is denoted using the letter A13. It is notation A13. It is sign, we call it as, it is actually nothing but it is signed minor. That means minor को sign दे देना. So sign कैसे दे देंगे? It is just -1 to the power I plus j. So either 1 plus 3. Then it's minor M13. So -1 to the power 1 plus 3 is 4. 1 plus 3 is 4. -1 to the power 4 is positive. M13 is 4. That's all. So that is the definition of minor and cofactor. So minor of an element matlab just delete that row and column containing that element, remaining determinant. Cofactor of the element matlab it just give sign to that, sign to minor, minor को sign दे देना. और sign कैसे दे देंगे? -1 to the power its position ij 1 plus 3 I plus j. Okay, so that's all the concept of minor and cofactor. Clear? Okay, look at this. Write the minors and cofactors of the elements of the following determinant. We are not going to do each and everything. We'll do only one. Okay, we'll take one question here because the process is same only. Now, so you want to find M11, M12, M13, M21, M22, M23, M31, M32, M33. Minor of all the elements. So M11 मतलब minor of the element A11. So minor मिलने के लिए, so either A11 is 1, just avoid the row and column. Remaining determinant, देखो 5 into 2, 10, minus 1 into minus 1. 1 into minus 1 is minus 1. So minus minus 1 is plus 1. So which is equal
One.
to 11.
And
Similarly, M12, minor of the element 1, 2. This is the element. So just eliminate the row and column. Baki 3 into 2, 6 minus 0, which is equal
0.
to 6.
6.
A M13, minor of the element, this 4. Eliminate the column and row. Baki 3 into 1, 3 minus 0,
3.
this 3. Similarly, M21, this one. Eliminate the row and column. 0 minus 4, which is equal to
Minus 4.
minus 4. M22, this element. Eliminate the column and row and column. 2 minus 0 is equal to 2. 2, 3, this element. Eliminate row and column. Baki 1 minus 0, 1.
1.
3, 1, this element. Eliminate the row and column.
5 into 4.
0 minus 0,
0.
0 minus 20,
20. Minus 20.
minus 20. This element 3, 2. Column row gaya. Baki minus 1
Minus.
minus 12, which is minus
Minus.
13. And this element, last element, M33. Eliminate the column and row. Baki
5 minus 3.
5
0.
minus 0. 5 minus 0, which is equal to 5.
5.
So now corresponding cofactors. So A11 साइन टू माइनस या साइन आएगा साइन क्या आएगा -1 to the power 1 plus 1 into its minor. Minor is already 11. So -1 to the power 1 plus 1. 1 plus 1 is 2. -1 to the power 2. That is positive. So 11. So if sign दे देना then A12. So 1 plus 2 3 आएगा -1 to the power minus आएगा -6. A13 1 plus 3 4 sign positive आएगा 3. A21 2 plus 1 3. So minus, then minor is -4. So minus minus 4, it becomes 4. A22 2 plus 2 4. So sign is positive, minor is 2. A23 minus 2 plus 3 5. Sign is minus, the minor is 1, -1. A31 3 plus 1 4, positive, number is or minor is -20. A32 3 plus 2 5, it is minus, then -13, which is equal to 13. A33 3 plus 3 6 is positive, so 5. So that's all. So these are the minors and cofactors. Got it? Before going to that next question, I just want to tell you one property. So the sum of the product of the elements of any row or column with their corresponding cofactors. अब कोई भी एक रो, if any row or any column, if you multiply all elements with its corresponding cofactor. For example, तो यही example will take this example. Okay, so here you take any row or column. For example, I am taking third row. That means A31, and you multiply with its cofactor A31. plus A32 and multiply
A33.
with 32 plus
A33.
A33 and its cofactor.
A33.
So do you know what you will get if you multiply every element of a row, any row or column with its corresponding cofactor? Do you know what you will get actually? We will do it also, but here see this A31 क्या है -1 to the power 3 plus 1, then it's M31, right? Just eliminating the row and column containing that 31, isn't it? Sign to minor. Similarly, A32 is -1 to the power 3 plus 2 into, just eliminate the row and column containing that, that is M12. Similarly, A33 cofactor is -1 to the power 3 plus 3 into its minor, correct? So A31, so plus A32 plus A33, isn't it? And this is nothing but this is known as a determinant, right? Isn't it? It is nothing but the determinant. How? Obtained by expanding along third row. Third row से expand कर रहे हैं ना ये. This is actually expanding along third row. -1 to the power, my sign -1 to the power 3 plus 1, then that row and column deleted, बाकी जो आया, that is known as that minor, then into that element plus again second element into sign -1 to the power 3 plus 2 into the row and column, deleting the row and column containing that 2, that is nothing but minor of that element, plus third element into sign its sign into the row and column deleting the row and column containing that 3, so remaining is its M33 minor. So this is nothing but you are expanding along the third row. Okay, so that means if you multiply any row or any column with its corresponding cofactors, and we will try to prove it also, means we will verify this. A31, A32, A33 से हो जाएगा -1 to the power 3 plus 1 into, eliminate the row and column containing, that is 3, 8, 0, 1, isn't it? So which is 3 plus 1 is 4, it's positive, 3 into 1, 3 minus 0, which is equal to 3. This is -1 to the power 3 plus 2 into, eliminate the row and column containing that 2, it is 5, 8, 2, 1. So sign is minus 5 minus 16. 5 minus 16 is minus 11. So minus 11 is plus 11. This is -1 to the power 3 plus 3 into 5, 3, 2, 0. 3 plus 3 is 6. Sign is positive. 0 minus 6, it is -6. Now just try to find A31 into its cofactor plus A32 into its cofactor plus A33 into its cofactor, which is 1 into 3 plus 11 into 2 into 11 plus 3 into -6, which is equals 3 plus 22 minus 18 which is equals 22 minus 18 is 4, 4 plus 3 is 7. So you just try to find the determinant by using any of the row or column. I'm just trying to expand along first row. 5 into sign is also plus, because 1 plus 1 either sign minus either sign plus. 5 into eliminate the row and column containing 5. So remaining 3 into 0, 0 minus 2, then minus 3 into eliminate the row and column containing 3. That is 6 minus 1, plus 8 into eliminate the row and column containing that 8. 4 minus 0. 0 minus 2 is minus 2 into 5 plus minus 10, minus 15 plus 32. So minus 25 plus 32. You can say which is equal to 7. So from here, what we understood is when we multiply the elements, that's what here, it's the sum of the product of elements of any row or column with their corresponding cofactors, then the value will be always the determinant. Okay. So what will happen if you multiply with the cofactors of any other row or column? For example, just I'm A11, first row, first column element, and I'm multiplying with the third row, first column cofactor. A12, but I am multiplying with the cofactor of third row, second column. A13, and I am multiplying with the cofactor of third row, third column. So here what I did is I'm multiplying every element of first row with the cofactor of the corresponding cofactor of the third row. So what you will get? We'll check it. A11. A11 is 5, and you got the cofactor as 3 there, plus A12 is 3, corresponding cofactor is 11, then it is 8 into corresponding cofactor is minus 6. So 15 plus 33 minus 48. So that is 48 minus 48, which is equal to 0. Look at that. So that's a point told here. If element of a row, a column, are multiplied with the cofactors of any other row or column, not with their corresponding cofactors, multiply with the cofactors of any other row or column, then their sum is 0. So here I have shown you that. Here third row, when I multiplied the third row with the cofactors of the third row itself, you got 7. That is nothing but the determinant of that. So अब कोई भी row, if you multiply any row or any column with their corresponding cofactors, the answer will be always determinant, because that is definition only. Here you can see when you multiply with the corresponding cofactor, this is nothing but you are getting the expansion along a row, not a column. Okay, so it's a determinant. But if every element of a row or column are multiplied with the cofactors of any other row or column, you can see that the sum is 0. So here मैंने क्या किया? What I did is first row element I multiplied with the corresponding cofactors of the third row. So you can try with any other row also if you want, and we can verify the answer. You got it? So now we will do the question number 4 and 5 very fast. So before going to question number 4, see question number 5. The value of the determinant. which one will be the value of the determinant out of these four options? Out of these four options, which one will be the value of the determinant? Tell me.
Option 4 D.
Option D.
Yes, sir.
Yeah, because we can see that A11 first row first
A
column उसका corresponding cofactor, A21 उसका corresponding cofactor, A31 उसका corresponding cofactor. So if you multiply that and then add, you will get the determinant. The remaining cases you can see that it is not the corresponding cofactors of the same row, it is the cofactors of the other row. Okay.
Yes, sir.
Yeah. So in those cases the value will be 0. Only the value will be the determinant only when if you multiply with the corresponding cofactors of the same row. And question number 4. Using cofactors of elements of third column. So third column, this is a third column, right? Using cofactors of elements of third column, evaluate the determinant. So third column use करेंगे तो third column A13 into its cofactor plus A23 into its cofactor plus A33 into its cofactor. So we have to find A13. So it will be minus 1 to the power 1 plus 3. Then determinant obtained by deleting the row and column containing that 1/3 element. So it will be 1 y 1 z. So it is positive. 1 plus 3 is 4 positive. So आपको मिलेगा z minus y. Similarly, A23 minus 1 to the power 2 plus 3 determined obtained by eliminating the element A23. So it is 1x 1z, which is equal to x minus z. Now A33 minus 1 to the yeah, sign is there. Here sign is minus of x because 2 plus 3 is 5. So minus of x minus z, or you can say it is z minus x. Minus 1 to the power 3 plus 3, the determinant obtained by deleting the element A33, that is 1x 1y, which is equal to y minus x. Now we know that determinant is you have to multiply the elements with the corresponding cofactor. So determinant is that element y z into its cofactor z minus y plus zx into its cofactor z minus x plus xy into its cofactor y minus x. Now you can simplify and write the answer, that's all. Okay, either you can leave the answer here or you can simplify. This is equal to yz into z, yz square minus y square z plus z square x minus z x square plus xy square minus x square y, right? Isn't it? Yeah, you can simplify or you can just leave it the answer like this. जो term है z square है, if you take that common, you will get z square into z square common, then either x plus y y square कॉमन निकालेंगे तो बाकी x माइनस z here minus x square कॉमन निकालेंगे तो y plus z. That's
Yes,
okay
sir.
because they didn't ask you to prove it is equal to something, just evaluate. So that's the answer.